When people imagine the possibility of first contact with extraterrestrial civilizations, they typically picture scenarios rooted in a sense of hope and peace. Giant spaceships hovering gracefully above Earth, or wise, benevolent beings transmitting calm messages of peace and cooperation. This idealized vision of alien life, influenced by science fiction and human optimism, suggests a peaceful encounter with a steady, thriving civilization. However, a radically different hypothesis challenges this conventional view, presenting a much darker, more chaotic scenario. According to David Kipping, an astrophysicist at Columbia University, the first extraterrestrial civilization that humanity detects is likely to be an unstable, extreme, and noisy one, possibly on the verge of collapse or nearing the end of its existence rather than at its peak. Kipping's hypothesis, known as the Eschatian Hypothesis, introduces a new perspective on the nature of first contact. The name Eschatian is derived from the Greek word eskatos, which means last or final. It refers to the idea that the first signs of intelligent extraterrestrial life we detect are likely to come from a civilization in its final stages of existence, a civilization that is in the midst of a crisis, possibly facing its own extinction. This theory is based on the assumption that most civilizations, including human ones, may not follow a steady, unbroken trajectory toward sustained stability. Instead, they may experience a period of intense, extreme activity just before their downfall, making them more detectable by alien-hunting astronomers. The core premise of the Eschatian hypothesis is relatively simple. The first techno-signature we detect from an alien civilization will not come from a steady, calm society. Instead, it will likely come from a civilization that has temporarily become extraordinarily bright or detectable, either by accident or by design, at the end of its existence. This could be due to an unsustainable technological leap, a crisis resulting from environmental or social collapse, or a desperate attempt to escape an inevitable fate. In short, the aliens we detect may not represent the calm and collected beings we often imagine, but rather chaotic, unstable civilizations on the brink of destruction. A historical pattern in astronomy to understand why Kipping believes this scenario is more likely than a peaceful first contact. One must consider how astronomical discoveries have unfolded historically. In the study of the cosmos, astronomers have consistently found that the first discoveries are often the outliers, those objects or phenomena that are rare, extreme, and distinct from a norm. These early discoveries are not necessarily representative of the typical, stable state of things in the universe, but are instead the easiest to detect or the most anomalous. For example, one of the first confirmed exoplanet discoveries occurred in the early 1990s, when astronomers detected planets orbiting pulsars. Pulsars are dead, rapidly spinning stars that emit beams of radiation in regular intervals, creating a kind of cosmic lighthouse effect. These pulsar planets were a remarkable and unexpected find because they are extremely rare. The conditions for a pulsar planet to exist are highly specific and unlikely. Nevertheless, these planets were discovered first because the timing signal of the pulsar was so sharp and regular that tiny changes could be detected. The planets themselves were not the norm for exoplanetary systems, but their unusual orbits and the specific conditions of pulsars made them easier to identify in the early days of exoplanet hunting. Similarly, the discovery of hot Jupiters, large gas giant planets that orbit extremely close to their stars, was another case where early discoveries were of extreme or unusual objects, not the typical exoplanets one might expect. Before the year 2000, a significant fraction of known exoplanets were hot Jupiters. These planets were discovered primarily because their large size and proximity to their stars made them more easily detectable using the technology available at the time. It wasn't until later that astronomers realized that hot Jupiters were quite rare, orbiting less than 1% of Sun-like stars. Once again, the first discoveries were the exceptions, not the rule. The night sky itself offers additional lessons in this regard. A third of the stars visible to the naked eye are red giants, stars in the final stages of their life cycle, bloated and nearing the end of their existence. While red giants are relatively easy to see with the naked eye, they represent only a small fraction of all stars in the galaxy. The majority of stars in the universe are still in their main sequence phase, where they burn hydrogen and are stable over billions of years. Yet when we look up at the stars, we see many more examples of the brief, unstable red giants than the more common, stable stars. The same pattern holds true in the case of supernovae, massive explosions that signal the death of a star. Though a galaxy like the Milky Way only experiences about 2 supernovae per century, modern surveys detect thousands each year. The reason for this is simple. Supernovae are incredibly bright and detectable over vast distances, making them easy to spot, even though they are rare events in the cosmic timeline. Implications for the search for extraterrestrial intelligence. Kipping's argument is that this historical pattern of detecting rare, extreme events in astronomy could hold true for the search for extraterrestrial intelligence, SETI, as well. The first techno-signature, or detectable signal of an advanced alien civilization, is more likely to come from a civilization in crisis, rather than one that is stable and thriving. The idea is that such a civilization would have reached a point where it is producing vast amounts of electromagnetic radiation or other detectable signals in a way that is much more visible than the quieter, more stable signals of a typical, long-lasting civilization. In this sense, the Eschatian Hypothesis suggests that the first alien signal we receive might not be a peaceful, calm transmission, but instead a chaotic and unstable signal that could indicate a civilization teetering on the brink of collapse. This could be the result of a civilization's over-reliance on technology, a massive environmental catastrophe, or an existential crisis that causes them to emit extreme signals as a last-ditch attempt to communicate or survive. This kind of signal would likely be very loud, detectable across vast distances, and distinct from the background noise of the universe. This scenario challenges the more optimistic views of first contact. Instead of imagining an advanced civilization sending us a peaceful message, we might be faced with a desperate, chaotic signal from a civilization in decline. Such a civilization might be broadcasting its final attempts to communicate with anyone who might listen, using powerful, unstable technologies that are difficult to sustain. This would make their signals more detectable, but it would also suggest that the civilization behind the signal might not be around for much longer. The search for technosignatures. The concept of technosignatures, the detectable signs of advanced technological civilizations, has become a central focus of modern SETI efforts. In the past, astronomers primarily searched for radio signals from alien civilizations, but the scope of technosignature research has expanded to include a variety of potential signals, such as optical emissions, artificial light patterns, and even potential evidence of megastructures like Dyson spheres. As we search for these signs, Kipping's Eschatian Hypothesis offers an important caution. The first technosignature we detect might not be from a civilization in its prime, but from one on the edge of collapse. This idea presents a profound challenge for the field of SETI. It suggests that the signals we are looking for might be far less predictable than we had hoped. Instead of steady, peaceful transmissions, we might be looking for brief, unstable, and highly energetic bursts of activity that indicate a civilization in crisis. The search for technosignatures might require a more nuanced understanding of alien civilizations, one that accounts for the possibility of short-lived, extreme civilizations that burn brightly but quickly fade.